Good evening, all. Hi, this is Dr. Jyoti Para, the founder of SEEWA, Socio-Economic Empowerment of Women Association, where we are empowering women in entrepreneurship aspects. And every webinar that we are conducting is in relevant to how to start a business, brainstorming of ideas, and various other aspects, wherever we can support a startup or a new entrepreneur. So we are trying to chime in and give more data there. So today's session, we have Dr. Suchi Tiwari, who's a professor and who's working in a university. So she has come up with R&D, bridging the gap between research and development for the startups, especially the research as well as the certification, the test required for certain products specifically related to cosmetics or any testing certifications which are required. So she has come up with a great idea where she is enabling startups to take care to start up to properly get into the certification aspects or the research and development required. They're trying to enable it. So let's listen it from Dr. Suchi herself, what exactly they are doing and how can they really enable the startups, specifically women empowerment and entrepreneurship. So Dr. Suchi ji, it's over to you. You can go
Yeah,
ahead taking the session. I'll share the presentation.
slides. Thank you. Yes, yes. Good evening, everyone. First of all, I'm thanks to Jyoti. She's giving me opportunity to give this presentation. So we know research is not a new idea. The main thing is there how we can this research with associated with the startups, because the startups we know from the industries or the high scale industries, they have their opportunities, they have their R&D labs and things are there. But the startups, for everything they have to be focused on their money part. So if they are associated with the some research labs or somewhere in the IICT or any research labs or maybe the IITs, so they are benefited. So what is my idea? Ki why not we can go for the startups and we can give whatever we know about as accommodation, and we can collaborate with the startups and we can do the work. So that is my idea for doing this presentation. And it's not only related for the chemistry only, because the VNR VGIT there is a technical engineering technical college, so we have a lot of other facilities also there. So you can visit the website in the college and you can go for the CAT cam is there. We have the very good robotic labs, we have the all sensors and all these things are there, which is from the other faculties are doing, and they are very happy if anybody approach to us and do the work. So that is the main criteria for I want to associate it with the startups and know what is their real problems, what are the especially from the research side, and how we can able to solve it, and how we can connect from the other person other institutes that will be the my main motto. Ma'am, just share the slides. Hello.
Yeah.
Yes.
Are you able?
So yeah, I'm able to
Okay.
see it. I just put it next, then you can go for the next.
Yeah,
So yeah. So what happens in the my slide first? First of all, I want to unlock whatever the locking is there, because we know if any startups or any industries, if we are saying for the accumulation, they are saying no, 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 we want to not do anything. From the, any government funds are coming, especially from the CSIR or DST. So startups or industries are not willing to do the work. They are saying it is a very time consuming. So I want to bridge this gap, because all the institutes, all the research labs or any CSI or DST funding agency, they want the real problems. They don't want anything which is from only happen in the research lab and it will be stopped. They need the things which is going from the society. This is a useful for the society. If it will be there, then they are ready to give the very good funds, very huge funds, which will help to your develop the product in the various way. So that is my main title of this, bridging the R&D gaps, empowering the startups, and how we can go for that one. So we can basically whatever that we are doing, we are doing for the benefit of society, benefit of our economy and our environment. So definitely everyone aware about our SDGs. That the 17 SDGs are there, and these are the connecting from the all these things, and whatever our products are there, that we can go in the that direction. Then it will be very useful for the funding point of view, and you getting the funding very easily if you are focusing in the SDGs. That is the main motto from the any startups. If you are focusing in any form of the SDG, and you have to be make it from the real contribution of the SDGs, they are ready to give the funds. Next slide. So what are available in my college, which we are doing the work in the presently, and the so many students are doing the projects, and we are also doing the work. So first we have the very good additive manufacturing and 3D printing. Various of the 3D printings are there, so you can come and visit and see our printing labs. And then we have the CAD CAM computer aids. We have the more than 100 different type of the designings and manufacturing things are there. Then because we have the chemistry department, we are focusing not only from the theoretical chemistry, we have the very good knowledge about the computational chemistry as well as some chemistry softwares also. And the ECE department, in our ECE department, they are doing a lot of work in the sensors and membranes. And we have the instrumental department is also there. So some good instruments like IR, NMR, all are present in our college. And we can, from the consultancy basis, we are doing the analysis also. So that will be there. And for the other details, you have to go further this one. So what is my purpose of doing this presentation? First thing, I want to, whatever the work you are doing, how we can go for the scientific prospects. What are the scientific prospects will be there? And for that, definitely we have to require go for the instrumental analysis, then go for the interpretations, and then whatever work you are doing, other industries or other research labs or academic institutions like IITs, NITs, ICER, if they are doing the similar work, their research are doing the similar work, so we can go for the collaboration. They are very happy. If we are going from some startup will be coming, they are very happy. So that we are going from this one. And after that, because we are going, because in the accumulation we have the so many calculations, all these things are there, so we can going from the calculating the carbon footprints, or maybe going from the greener futures, whatever work you are doing, that also we can go from the society, how much carbon footprint we are gaining or we are losing, how we can reduce it. That also we can go further this one. Next slide. Next slide. So for this, or do, ma'am, previous one, madam. Ma'am, previous one, madam, not this one. Ma'am, previous one. This one. After that, this one. Achieving this one only. Yes. So when we are doing this scientific work, we can go for the industrial instrumental analysis and all these things. So first, what will be happen once we can go for the scientific or we can go for the instrumental, we have to understand what principle or what things we are able to do it, and if any products are there, so we can improve their quality and also go for their applicability. What were, for example, if you are taking the example of the millets, you are making the any millets, and then you have to raw millets will be also there, and the product is also there. So we can see in the instrumental analysis there in the millets, whatever the structures are there, are they disturbed in the final product or they are a same one? So if it is not disturbing, then it is a very good point. We can say with the assurance, because we have the proof of the instrumental analysis from the IR or maybe the NMR, and then so for that we can go for this. Is I gave the one example. There's a lot of examples are there. Whatever we are doing, if we are putting in their instrumental analysis, we have the support proofs of that one. And not only from that way, once if you are doing the already analysis, then we can do the interpretation. So we can publish our work in the high impact journals, that we can our work is visible globally. You have to go for their scientific citations is also there. So many persons, they are able to learn how the work is going on. If you're going from the China is doing the same criteria. They are making and they are publishing work and they are making in the startups. And if you're going from the Patanjali, if you're seeing the Patanjali also, they are also doing in the same area. Ma'am, previous slide only. Previous slide only. Slides are going. So if it's so, we can able to publish in the high impact journals, and then we can extend the collaboration with the leading industries, research labs, and academic institutions, because we know the team work will be giving the more impact rather than being doing the alone. If the startups and academics are collaborate, definitely it will giving the very good team. Then we can trying to give the practical solutions in the challenges of chemistry, what we can do, how much percentage we can add. If we can add, we can use this one solutions, or we can add these things, that we can go for that one. And then we can, for this we can able to conservation through the accurate carbon footprints, their assessments and their audits. That is that part we can go for the later. We are doing the work in the sustainability point of view, so that will be there. Next slide. So what are the, I just take the few examples, not all the examples, but I am taking the few examples. For example, we are taking the additive manufacturing. So additive manufacturing, everyone know it is a very quick and cost effective. But in the labs, we are making the simple things because we don't have any type of any problem statements are not there. Problem statements are there, but it is only from the limited problem statements. But if we are collaborate with the startups, then what happens? We have to know the what are the real problem statements, what real shapes they wanted, what type of the material they wanted. So we are going in this way. So we the collaboration between industry and academic in the field of additive manufacturing, it giving the two-way flow of knowledge. So it will be, we are able to make the real materials, real designs, and real challenges will going on. So from the, we know the academia, we have the expertise in the advanced materials. We know that this material is very advanced and these principles in all these things are there. But we are not able to connect with the startups. So that is the thing. If the startup will become, and we can say from this thing, that will be coming. Second, we can go for the CAD-CAM. If we know the CAD-CAM technology, it means we are able to develop the so many type of the structures in the theoretically way. No need to go for the so much practicals. So we can go for the joint training programs, we conduct the workshops, and that opportunities are there. We have the well-established lab. So we can go for that one, and then we can go for the how our product will be visualized. What are the things are there? And it will be giving the cost saving also. Instead of doing the work in the practically, we can do the theoretically, and which one giving the very possible results, that we can put it in the practical point of view, or we can go for their commercialization. Then it's coming from the software side. If you're going with the molecular structures and all these things, so we can use a computational chemistry, we can go for the software developments. So we can take the different type of the structures, we can put it only from the theoretically, and we got the products. Different type of the products, their complete analysis, they will give it in the 30 point of view. Then which is giving our more productive results, that we can put it in the experimental point of view, and again we can comparison. Whatever we put it in the theoretically, whatever we did in the practically, are it same or not. If it is not same, then again we can go for the change that their calculations, their reactants, their products, their catalyst, and all these things we are going from this one. So it will be very good things. Do the less work with the computational chemistry or maybe the softwares. They will design the products in such a way that this is our own product. And then same thing we can go for the make it in the practical point of view, and then we make the practical products. That will be there if we are exploring the softwares in the different way. So we can go for the membrane technology. There are a lot of things are there for the applications of biosensors and all these things. We are going from the software. Software will tell this much will the yield will become, this much yield will be not come. If we change the catalyst, what will be happen? If you not change the catalyst, what will be happen? What the solutions will be there? That all details are coming in the software. Based upon that one, then we can go for our final product. Next one. So what analysis should be required for any product, any material when we are synthesized, maybe eatable or maybe anything. So first we go for the spectroscopy. That's first we can go for the FTIR. There's a Fourier transform infrared spectroscopy. For that, we can able to identify what are the functional groups are present and how the material will be working. We can go for the raw product, we can go for the final product. What are the changes are there that we can identify there. Then we are going from the NMR, nuclear magnetic resonance. There also we can go for their molecular structures. What are the molecular structures are there. Then we can go for the one more, that is called the UV visible. There we can go for the what are the double bonds are present, what are the concentration will be there, what are the interactions will be happen. For this we can able to identify what are the our material. We have to a little bit knowledge will be coming in our material. Then we can go for the second is called the chromatography. In the chromatography we can go for a lot of chromatographies are there, but generally we are going from the gas chromatography for the molecular weight distributions, and second one we can go for the HPLC. In the HPLC, high performance liquid chromatography it's called. So for that we can know how much my product will be pure and what are the exact composition will be there. So that we are going that we can identify with the HPLC. And then we can go for what are our structure. Initially, what are the structures are present, that we can go from the scanning electron microscope or maybe the AFM, that is giving the surface morphology. And we gone to very particular from the any skin products or anything that we are making, especially from medical point of view, then we can go for the TEM analysis, turning electron microscope. They are giving the high resolution of the structural imaging. Then if any product we want to the thermal stability, then we can go for this thermal analysis, that's called the thermogrammetric analysis. If any material which we want to go for their behaviors from the surface tension, it is some liquid, how it will be the, it is a water affection or it may be the water repulsion, all this we can go from the rheology. I give the just at a glance what are the things, what are the instrumental analysis are there. There are a lot of many analysis are there, that which depends upon the tailor made what are the products we have, but the generally we are doing in the this analysis. Next one. So for this, if you are doing these things, so what are the main motto of the any products presently, they want to green chemistry. Green chemistry, it means there is a 12 principles are there, we know, so many person maybe know or don't know, but there is a 12 principles. The basic concept of these 12 principles, how we can reduce the pollution, how we can reduce the toxicity, how we can reduce the adulteration, which is the major issue of the any type of the products. Even though we are using the floor cleaners to toothpaste from the oil, anywhere we are not able to identify it is the pure or what are the things are there, what toxic materials are there or not there. So this is the main things will be there in this one. So these are the 12 principles are there, based upon that it will be there. So right now also in the presently also there are so many NEP, national education policies came, everything is came, but still somewhere we are lag behind, we are not able to connect with the industry and academia. Even the startups will be coming, academia is not giving that much positive response, same thing from their side, but possibilities are there. If you seeing from the social commitment approach, industries is also want do the social work and universities also want, but how we can connect these things, that will be the major issues are there, that we have to solve. When we are connect, when we are sit and when we are resolve the issues, what are the issues are coming to us, then only we are able to do it. So there is a three criteria will be there, we know, from the industries, from the social impact, or maybe the whatever the R&Ds we are doing, and what are the learning outcomes. From the industries we need the skills, but from the universities we have to be giving the so many programs, so many certificates are there, but that certificates where they have to apply, that is a major issue, because they don't know. They are doing a lot of certifications, the students are doing a lot of certifications, but they don't know where they have to be applied. Once they are going, then again the industry is saying this application, this certificate is not at all useful. But if it's connected, then they know startups are required this type of the certificates. Startups say to academic, we need only this type of the certificates, or we need this type of the skills, that will be coming. So a main thing is that why this industry academia initiations are failed, why we are still struggling to connect from the not only industries, startups, industries, I mean, even industries also, in a well established industries also not interested to do the work with the academician, because they are saying it is a time consuming, it is a, so many formalities are there, so all these things are there. So that is the major issue from this one. Then what are the major aspects on this one. So if you see, clarity of the technology roadmap is not there. Idea generation is major problem. Politics and bureaucrats, that is the major issues are there. Then converted idea into proposal, that is also taking the time. And the major issues, whatever the things are, the fundings are not at all available. Everyone wants the funding, but the fundings are not at all available. Then the relationships and communication is the major problem. Then the convert the proposal to the projects, that is also the proposals are there, but how we can go for the commercialization, how convert it in the project, that is also. Right now some scenarios change, now the students are focusing in the startups, but initially they are focusing in their jobs and all these things. But now the 2%, 3% or 5% students, still they are saying okay, we are going from the startups. So that will be there, but that is the percentage is very low. There's so many reasons are coming, and that the reasons they are going from the low. Next slide. I think slide will be stuck.
It's working?
No, slide will be stuck, I think.
No, it's not. It is actually showing a bit of internet problem at my end. In case we get disconnected, please connect
Hmm.
back in 10 minutes. No issues. We will get into another, internet connectivity and we'll work. But the slides are working, ma'am. Please check.
But it will be stuck. This is the university industry. After that, next slide.
Give me a second.
Uh,
Have you got it?
yes, yes, it's recorded.
Is my screen viewable? I mean, do you see the next
Huh.
slide? Okay.
I'm not able to see the next slide.
It's playing at my end.
No, Jyoti, it got stuck.
Oh, is it?
Yeah.
Is this okay now? Is it working?
Yeah.
No.
No,
Yes.
it's fine.
So in the from whatever the what we can go for the collaboration with the startups, and first we have to decide the research priority and our objectives. What research we want, then we can go for the resource sharing and the fundings. What are the fundings are, because a lot of government fundings are available from the academia point of view. They are not giving to startup, but they are giving to academician. If we are with the collaboration, we can take the fund and we can do the research. Then definitely IPR will be the one major issue. We have to be see and go for that one. And then the cross disciplinary collaborations, you are doing the work in the some area, you want to from another area, that also we can go for that one. And the important thing, whatever the research, whatever the work we are doing, we have to focusing on the green product design and developments. Next slide.
Suchi ma'am, are you able to see the slides?
I am able to see the slide, but slide is not moving, ma'am.
Oh, it is moving here. I think we're having just one or two slides. How come?
Yes.
Have you got it?
No, no, ma'am. That slide only. Or otherwise, I will share with my slide.
Yeah, just check out once. I think it's in play with me. I mean, it's working.
Okay, okay.
So as I said, it's showing internet unstable for me. So probably that's why it's
Mhm.
taking time. In case we're getting disconnected, please log back when with the same link, the same meeting link in 10 minutes. We should be able to resume. It's working at my end. Are you not seeing sustainable e-waste management, ma'am?
No, no, ma'am.
No, that's only one slide left on your presentation right now.
No, no, no. There is a 14, 15, 16, 17. There is a two slides are there. 14, 15, 16.
No, you want 14, 15 also. Okay.
14 is completed. 15 you can put it, madam. No, yes. So what we have to go for the shaping future, identification of the common interest, scoping and planning which should be required, research and development we have to go for, then the product and data sharing, prototype testing, all these are the things. These stage, there are a lot of things are there, and then we can go for the scientific publications, we can go for the commercialization deployments, then we can, whatever the things we are doing, we go for the towards sustainability. So we know these are the different steps are there, and it is not a linear. It's showing here in the one page is very easy, but when we start the collaboration, lot of complexity will be coming in the multiple projects and the so many things. But we have to be make it, and we have to trust from each other, and we can do the successfully, and then definitely this collaboration giving the very fruitful results are there. Next slide, madam. So we are able to connect with the different IITs, CSIR labs, ICER, the central universities, state universities, deemed universities, because I have the direct connections from that one. Then we can go for the different professional memberships also. This will be the very good platform. If you are joined the any memberships, lot of persons are doing the different works. So you have to go for the from the Indian also, maybe the globally also, American Chemical Society, International Society of Industrial Ecology, Indian Chemical Societies, and all these things societies are there. You can make the membership. Everyone is welcome from this memberships, and you can do it from this one. Next one. So because I started work, this is my passion. I want to join, I want to connect with the startups and this one. So I started from the first work from the Maya. She is from the Holy Waste. So we just published one patent from the flowers powders, from the how to make the activated carbon. And